We're going to look at what the difference is between the isoelectric pH and the isoionic pH of a protein with different acidic and basic substituents. The isoionic pH, or isoionic point, is the pH when the pure neutral polyprotic acid, or the Zwitterion, is dissolved in water. The Zwitterion molecule has an equal number of positive and negative charges and no ionic species. The isoionic point is the net charge of 0 in a deionized solution. Concentrations of H2A plus and A negative are not equal to each other. The equation for isoionic pH is given in terms of the concentration of H plus in solution. The equation is the isoionic point is K1 times K2 times F plus K1 times KW, all of that over K1 plus F and the square root of that. And again, that will equal the concentration of hydrogen in solution. The isoelectric point, or isoelectric pH, is a pH when the average charge of the polyprotic acid is 0. Most of the molecules are in the uncharged form, and the concentration of H2A plus and A negative are equal to each other. The equation for the isoelectric pH is isoelectric pH is equal to 1/2 the sum of pKa1 and pKa2. The difference between the two is that the isoelectric pH is the pH value at which the net charge of the molecule, including bound ions, is 0. The isoionic point is at net charge 0 in a deionized solution. The two are equal to each other only when the concentration of charged species is 0 in the solution. So now we can look at how to solve an equation of both isoionic pH and isoelectric pH. We're going to be looking at 0.1 molars of alanine. So we have the equation of isoionic pH. Again, you need to look up all the Ka's and the F's. Now the F is equal to the formal charge of the molecule in solution. So that's going to be 0.1 molar of alanine. All of the K's, Ka1, Ka2, and Kw can be found either in the back of the book or online. So next we need to plug all of the numbers into the equation, take the square root of the numbers, and we end up with a hydrogen concentration of 7.7 times 10 to the negative 7th molar. Now that is the concentration of H plus, and what we need to find is the pH. We do that by taking the negative log of H plus, and we end up with an isoionic pH of 6.11. Now for the isoelectric pH, we see that the equation again is 1/2 the sum of pKa1 and pKa2. The pKa's can easily be found in the back of the book in one of the appendices or again online. So add pKa1 of 2.334 and pKa2 of 9.868. Take 1/2 of that and you see we get an isoelectric pH of 6.106.